So, welcome to Service Mesh Academy. Today we're going to be talking about Linkerd 2.18. Sadly, you're stuck with just me for this Service Mesh Academy. So, as always, join in the workshops channel on the Linkerd Slack or chime in here on the chat if you want to. This would be the workshops channel on the Linkerd community Slack. But with that out of the way, I think we're going to go ahead and get started talking about Linkerd 2.18. So, on the agenda for today, we're going to do a really quick intro to Linkerd, just in case people are somehow unfamiliar with it. We're going to talk about the new features in Linkerd 2.18 and why you should care about them. We will be interleaving demos with presentation because there are 3 separate things we want to talk about, and so we're going to try this format. And as always, we will talk about the gotchas with the new features. If you want to follow along, and we hope you do, that QR code will take you to the Service Mesh Academy GitHub repo. I will be using Buoyant Enterprise for Linkerd 2.18. If you would rather, you can use Linkerd Edge 25.4.4 or later. I would recommend going straight to 25.5.2. I am going to change it up this time and use a pair of kind clusters. Since we are going to be talking about multi-cluster, I'm using 2 of them. That's mostly because I already had a multi-cluster setup running with kind. You can do this with K3D, it's fine. The main requirement is we will be using federated services, so you must have pod-to-pod networking between the clusters. That means that a pod in the cluster called East must be able to make a direct IP connection to a pod in the cluster called West. If you don't have that, federated services won't work yet, so that's a requirement. You will also need the kind CLI, the kubectl CLI, the Linkerd CLI, bat, JQ, YQ, Python. I really should have put Damash up here because the easiest way by far is to go and run the README using Damash. Let's see if I have a caption for that one. I don't. I should add one. Anyway, go to the Buoyant.io GitHub repo and you will see it there. That's the easiest way to run it, but you don't have to. You can just copy and paste commands on your own if you like. And of course, you don't have to follow along and do everything yourself. You can just watch the workshop. We just think that's a little less fun. So, quick intro to Linkerd as promised. And again, if you have questions, drop them in the workshops channel on Slack or drop them in our chat here, and we will get to them as we can. Quick intro to Linkerd, though. Linkerd is a service mesh, meaning it's an infrastructure layer dedicated to providing security, reliability, and observability at the platform level underneath your application, across the entire application uniformly, without having to change your application. Service meshes mostly came about due to the whole microservices architecture, where you have things that are communicating over an insecure, unreliable network. The insecure and unreliable part is a fundamental characteristic of the way we build networking. It's not something you can just change at the network layer. So instead, you put in a service mesh to make things better. The mesh, well, like most of the other meshes, Linkerd works by adding a sidecar to each of the application pods. And the point of the sidecar there, that sidecar proxy, unlike the other meshes, is a purpose-built, lightweight, ultra-fast Rust microproxy instead of most of the other ones using envoys. The point is that the microproxies get to take over the network and then mediate and measure all of the communications happening between pods in the mesh. This is actually how meshes provide their functionality, is by mediating and measuring all of the communications happening in the mesh. The reason that this is relevant is that security, reliability, and observability are not optional. You have to have them. I have yet to hear of anybody sitting down one day to write an insecure, unreliable, unobservable application. You can get these things by running a mesh, or you can get these things by writing in a lot of application code, but you have to have them. We probably obviously think that adding them in the mesh is a better plan because it frees up your application developers to work on the business needs of the application rather than low-level annoying networking things. All right. That's Linkerd the really quick intro. Linkerd 2.18 is our latest major release of Linkerd. It came out in April, and it brings to the table 3 flagship features. We have decoupled Linkerd from the Gateway API CRDs. We have added protocol declarations, and we have added GitOps compatible multi-cluster functionality, which a bunch of people were asking about. We're going to talk about all 3 of those in some detail. We also have some improved things, like we have improved OpenTelemetry support. We have an experimental Windows build of the proxy now that's real. We've improved some things about federated services, and although you can't see it because it's buried under my name there, we've, of course, fixed some other bugs in Linkerd as well. So let's start by talking about Gateway API decoupling. Linkerd has been using Gateway API since the 2.12 release, which was a while ago. I don't remember exactly when. For the most part, if you installed Linkerd at any point between 2.12 and 2.17, if you did not explicitly tell Linkerd not to, it would install the Gateway API CRDs for you, because that's the easy way to let people get started with Gateway API, right? Gateway API has its own set of CRDs. If we install them for you, that makes it easier for you, the end user. Or so we believed. Gateway API is a shared CRD API, meaning multiple projects use it. And what we have found over time, and this is the broader community of people working with Gateway API, not just Linkerd, what we've found over time is that having specific projects try to manage the Gateway API CRDs for you, it turns out to be less than ideal. The root of this is actually that Kubernetes wants people to use CRD APIs, but Kubernetes doesn't really have a lot of built-in support for CRD APIs, and that puts us into some weird situations. There are 2 really major ways that this tends to manifest. One of them is, let's imagine that you install Linkerd, and Linkerd installs Gateway API, and it happens to install version 1.1.1. Then you go off and you create a bunch of Gateway API resources themselves to get your application working with Linkerd. This is great. And then you decide you want to use Argo. And I'm picking on Argo here, not because Argo does a bad job of this. I'm picking on Argo just because it was one that I already had the icon for, and we kind of like Argo. So, we're okay using it as an example. Suppose Argo wants version 1.2 of Gateway API, while Linkerd really wants version 1.1.1. This is a bad situation. Nothing really good can come out of this. Version mismatches are going to cause trouble if you're allowing the projects to try to individually manage the shared resource. Even worse, let's suppose that you do get Argo and Linkerd to agree on which version of Gateway API to use, which is less difficult than it seems like it might be. So you install Argo after you install Linkerd, and everybody is happy. And then you go through and you create a different set of routes to make Argo do its thing. Or maybe Argo rollouts is actually managing these resources for you, in fact. So you go along, and then at some point you decide that for whatever reason, Argo is not for you. So you remove it. And again, not meaning to imply that Argo is a bad project, just this happens, right? You pick a CD tool, you work with it a little while, you realize, this doesn't quite fit our workflow, let's find something else. At this point, if Argo believes it is managing Gateway API, Argo might decide to remove the Gateway API CRDs because you've uninstalled Argo. And if it does that, all of the routes will go away, including the ones you created for Linkerd that have nothing to do with the stuff that Argo was managing. This is a huge problem. Deleting the shared CRDs is even worse than version mismatches, because when you delete a shared resource like this, a shared set of CRDs, all of the resources that were created using those CRDs silently evaporate. And again, just to be clear, even though my name is covering this up, this behavior is not Argo's fault. This is the way Kubernetes works when you're dealing with CRDs. So not Argo's fault. Argo's great. We like Argo. Excellent. So the best practice for now, if you are using Gateway API, don't let any project manage Gateway API CRDs for you. Instead, manage them yourself. This means you install Gateway API CRDs before any of the projects you want to install that use them, and you only remove the Gateway API CRDs after you have removed all of the projects that are using them. This is not a great state of the world. We don't particularly like this. There is a lot of discussion right now in the Gateway API project about how we can do better, but this is the best practice for right now. For Linkerd in particular, this has a couple of interesting follow-on effects. If you are using Helm to install Linkerd 2.18 or to upgrade to Linkerd 2.18, our Helm charts assume that you have already done whatever it is that you need to do to deal with the Gateway API CRDs. We kind of don't have a choice in this because Helm has no ability to look into the cluster to see what's actually there for CRDs. If you're using the CLI to install Linkerd 2.18, the CLI by default will check to make sure that the Gateway API CRDs are actually there, and if they're not, it won't let you do the installation. If you're doing an upgrade, by default, it will look at the cluster, see what Gateway API CRDs are there, and then try to do the right thing, where the right thing might be do nothing, or it might be installing Gateway API version 1.1 experimental, but it's going to look at your cluster and try to do something sane for your particular scenario. In all cases, we have a command, or we have a flag rather, that you can set install Gateway API. It's a Boolean. You can set it to true or to false to override what would normally happen. So if you really, really want the Linkerd CLI to install the Gateway API CRDs for you, you can -- set install Gateway API equals true, and it will do that. Not the best practice, but you can get it to do it if you really need to. And you can also set it in the Helm chart. Worth pointing out, in Linkerd 2.19, the defaults are going to change to don't ever install Gateway API. So with Linkerd 2.19 and later, you will have to use install Gateway API if you really want Linkerd to do this for you. The best practices, if you are managing Gateway API yourself, if you're doing a greenfield install of Linkerd 2.18, you should use the latest standard channel release of Gateway API. If you are upgrading, or if you know you need to use egress, use the experimental channel instead. We can talk more later if anybody has questions about exactly why this is, but those are Linkerd's recommendations for managing Gateway API yourself, which again is what we recommend you do. So, first demo of the segment. Let's go and actually take a look at Gateway API decoupling, which more accurately can be described as, yes, you do need to install the Gateway API CRDs yourself at this point. So we already have two kind clusters running. In the repo, there's a script, setupbase.sh. You can run that, and it will set up kind clusters exactly the way I have done. That's mentioned in the README as well. The East cluster is already running Linkerd because I didn't want to wait twice to install Linkerd during this. We can see there Linkerd check is basically happy. The West cluster, and let me do this. There we go. The West cluster is not running Linkerd at all right now. It has yet to be installed. So we are going to fix that for the West cluster. If we just run Linkerd install in the West context and try to apply it to the West context like we normally would, this will fail because we have not installed the Gateway API CRDs, and it's not going to allow us to do this. So in this error message, it tells us exactly what to do. But I happen to know that Gateway API 1.3.0 is already out, and we have not yet updated that error message to mention 1.3.0. So what I'm going to do is I'm going to follow our recommended best practices, and I will install the latest standard channel Gateway API, which is 1.3.0. So far so good, right? Now that that is being installed, we can go and install the Linkerd CRDs. I'm actually going to interrupt this for a moment. Well, I guess I'll let it type the whole command first. After we have the CRDs, we then get to go and install the control plane. And we are going to be doing multi-cluster. Remember, that's why we have two clusters here. So We have a bunch of extra arguments on here to be very explicit about which certificates we want to use when we install Linkerd for our West cluster. You can read about this ad nauseum in our multi-cluster documentation. I've already created all of those things, and my camera just blinked. That was fascinating. I've already created all the certificates that we need, so this is just about pointing Linkerd install at those certificates to make sure that everything is good. Before I actually run that command, I am going to also show something here. If I do this, you can see that, yes, we have gateway classes, and we have gateways, and we have gRPC routes, we have HTTP routes, and we also have the old policy.linkerd.io HTTP route, which you probably don't want to be using anymore. So we do have our CRDs here and all as well. I just hit return to run the Linkerd install command, just, for the record. So now we're going to wait for Linkerd to finish installing there. This always takes longer than I really want it to, so it always worries me a little bit. It's just, it doesn't actually take that long. It takes like a minute. But if you're doing a live stream and something is taking a minute, literally 1 minute, 60 seconds, then it always feels way, way, way longer than it ought to be. And if we had somebody other than me on this call right now, we could be telling terrible jokes or something like that. So now is a great time to throw in questions if you have any. Hey, there we go. That looks good. Okay. So far, so good. All right. Linkerd is running in our West cluster now. We're going to go ahead and install the Faces demo as well. And we're doing this mostly just to prove that things are really working in the cluster we just installed Linkerd in. So I'm going to create a Faces namespace. I'm going to annotate that to say, yes, Linkerd, I would like you to make things that show up in this namespace part of the mesh. And then I'm going to use helm install to install Faces itself. I'm using a custom values file. The purpose of the custom values file is to turn off Linkerd, or turn off Faces normal 20% errors. So there's nothing terribly dramatic in there, but you can look at the repo and check that out. We just got a question about the repo itself. So here is the main Service Mesh Academy repo. Wow. You know what? Let's do this instead. Whoops. Let me not do that one. Let me bring up the actual, there we go, the GitHub repo, as opposed to the link to register for more Service Mesh Academies. If you go to github.com/buoyantio/Service Mesh Academy, in there's a directory called 2.18 features. And in fact, I will just go ahead and we'll just leave that. That's the repo. And actually, since we have a little bit of time, let me go ahead and grab the direct link there. You get to listen to me typing, I'm afraid. All right. There you go, if you want to be able to just go straight to it. github.com/buoyantio/Service Mesh Academy/tree/main/2-18-features. And thank you, Catherine, for putting that in the Slack. All right. I'm going to make sure Faces is actually running. It is actually running. We will go and grab the IP address of the service that's pretending to be our ingress. And if I do that, then I should be able to flip over to the browser that I just used for that. And I can go to 155.32. And we can see that Faces is, in fact, doing its thing. At this point, though, we're not really doing anything to prove that Gateway API is working. So let me come back over here. We will prove that this is working by throwing in some routes that will make this look different. We're first going to throw in a route that will take all traffic from the face workload going to the smiley workload and redirect it to smiley 2. When I do this, we will see those grinning faces turn into hard-eyed smileys. There we go. And we're also going to do a gRPC route that takes traffic going to the color service, but only for the center method, which is these 4 cells in the middle here. And those will go to the color 2 workload, which returns green instead of blue. Everything else will continue going to color. So if I apply that, then the middle cells turn green. Yay! So now we know that Gateway API is working, and we saw that we had to manage the CRDs on our own. And yeah, welcome to Linkerd 2.18. That's about it for Gateway API decoupling. We could show upgrading the Gateway API CRDs or using it with shared tools, and we don't really have time to do those things. So back to our presentation. Protocol declarations. So Linkerd started with, as an inspiration, the Hippocratic Oath, first, do no harm. We turned that into the Carcanocratic Oath. Adding Linkerd to a functioning application must not break the application. And from the very beginning, protocol detection has been an important part of how we do that. The idea behind protocol detection is you should ideally just figure out what protocol a given connection is using so that the user doesn't have to configure the protocol that it's using. And the reason you care about this is things like, well, if you're doing HTTP or gRPC, you want to do request level load balancing. So it's important to know that those protocols are in use. You can't just say, oh, it's TCP and carry on. Unfortunately, protocol detection does not always work. When it doesn't work, the connection gets treated as just opaque TCP, which is exactly what we don't want, because you don't get protocol-specific features like request level load balancing or retries or any of this nice stuff that we rely on. Detection fails usually in 2 ways. The first way is we rely on the client speaking first so that we can look at the first few bytes of the request so that we can figure out what protocol is going on. So in a server speaks first protocol, the client's just going to sit there and wait, but we actually need to know what kind of protocol it is before we can even figure out which backend to connect it to. So this is a big deal that detection can fail. Good examples of protocols like this would be SMTP and MySQL and things like that, or NATs if you want to be talking about things that have been in the news a lot for cloud native recently. Another way, though, is that if the client speaks first, but it doesn't speak soon enough, protocol detection will fail. We will wait up to 10 seconds by default for the client to say something so we can figure out what protocol it is. If the client does not say anything within 10 seconds, we go, oh, well, hey, it must be opaque TCP, and then we carry on. The nice thing about this is that it means that your application has at least a chance of functioning. The not nice thing about this one is that if you are running with weird loads, so some of your clients get slow, you can start seeing sporadic protocol detection failures that only show up under extreme load only part of the time. And that is just obnoxious. It also doesn't line up with the Carcanocratic Oath because in this case, we are doing harm to the application. We are preventing it from working correctly. So to deal with this, we taught Linkerd 2.18 how to pay attention to the app protocol field in the service declaration. If the app protocol field is set, Linkerd believes that you know what you set it to correctly, or rather believes that you know correctly the value that you set it to, and we turn off protocol detection. So it does not matter how slow the client is or if the client speaks first at all, we will trust you to have told us the correct protocol for this thing. Right now, we will support values of HTTP for HTTP, Kubernetes.io/H2C for HTTP2 cleartext, which also encompasses gRPC, but more on that in a minute, and Linkerd.io/opaque for an opaque TCP connection. Any unrecognized value we will treat as opaque TCP. The value gRPC is not a valid value and will be treated as opaque TCP. So be aware of that. If you're using gRPC and you want to use protocol declarations, use kubernetes.io/h2c. We can't actually just support the word gRPC because the definition of this field is that non-namespaced values, values that don't have something / something, are required to be things registered with IANA, and the word gRPC is apparently not. So we may end up adding linkerd.io/gRPC later, but we haven't done that yet for various reasons that mostly get into, there are some interesting semantic things that we have to make sure get plumbed all the way through and stuff like that. So let's get on to the demo of this. Demoing protocol declarations is, it turns out to be a little tricky. There are a lot of ways you can approach it, but yeah, it's a little tricky. So the first thing we're going to do here is we're going to add a deployment into our West cluster in the Faces namespace that uses this John LaBelle Network Tools image to give us a place to stand so that we can run curl and telnet and stuff like that. And we are deliberately putting that in the West cluster because we want it close to our already running Faces deployment. And we're deliberately putting it in the Faces namespace so that Linkerd grabs it as well. Now, if we take this and we tell it to run curl to Smiley, we get to see the raw data for a Smiley response, which is very exciting, I'm sure. But the most relevant bit in here that I want you to pay attention to is this xfaces pod header. That gives us the name of the pod that actually handled that request. This is not any funky Linkerd magic. This is the Faces application. All of its workloads put that header in so that you can tell which pod is misbehaving if something is misbehaving. Or in our case, we can tell, oh, hey, the Smiley2 workload is the one that handled this request, which makes sense because this is an HTTP request and we have an HTTP route that is grabbing all traffic to Smiley and diverting it over to Smiley2. Now, for that rerouting to work, Linkerd has to know that this is an HTTP request. So we should be able to break that by making that connection really, really slow so that protocol detection times out, Linkerd gives up and treats it as an opaque connection. And in that case, it should go to Smiley, not Smiley2. We can do that with telnet. If you are not familiar with telnet, it is an ancient tool. It's at least 30 years old. It's probably more like 40 years old. And it basically just, on the face of it, it just makes a connection to a given service and port and then lets you type at it. Since HTTP is a human readable protocol, this works. We can just type at it and pretend to be an HTTP client. If you do a little bit of reading about telnet, you will find that there is actually quite a lot more going on under the hood, but for our purposes, it's just an interactive way that we can pretend to be an HTTP client. To do this, what we're going to do is send these lines, which I've just copied. This is in HTTP. You make the connection, and then the client immediately sends over a verb, get, the URI that is operating on, which is just a slash in this case, and the protocol version that we want to use for this, HTTP 1.1. For 1.1, we also have to send a host header that tells it which host we expect to be talking to, which is kind of not really important for our purposes today. So we just set it to Smiley because that's the service to which we are connecting. But I'm going to send that, and then I'm going to sit here and wait for 10 seconds. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 6, 7, 8, 9, 10. And I'll wait a little bit longer because maybe I counted too fast, but I'm pretty confident it's been more than 10 seconds now. So I paste, whoops. Now I've just broken everything. So now you get to see the fun of trying to make this undo. All right. So what happened there was that I broke that by accidentally not copying the get. So there we go with that. Here's our telnet again, but more importantly, now I can get these and copy the whole thing again. And I have to wait another 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait a little bit longer. Paste the real command, do a blank line. There we go. And we can see, in fact, that the pod, the xfaces pod header is indeed smiley, not smiley 2. So Linkerd did treat this as just a raw opaque TCP connection. You'll also notice that this is in, funky case instead of all lowercase, and that's because it actually gets sent over with upper and lowercase, but the curl command translates everything to lowercase because that's the way you're supposed to do it for HTTP2. Okay. So yeah, handled by a smiley pod, not a smiley 2 pod. That's how we know that this got broken. How we know it treated it as an opaque connection. I'm going to recopy this command, and then for completeness sake, I'm going to do this again, but I'm going to send it really fast so that we can see that that time protocol connection does work, and we'll get a smiley 2 pod just to prove that this is really a valid way of doing an HTTP connection. I did it really fast this time, and now you can see that this is a smiley 2 pod. So let's go ahead and fix this by using the app protocol field to force Linkerd to treat this as HTTP, no matter how long the client takes to deal with it. We can edit the service. We can go down to the ports definition, app protocol HTTP. And now one more time, I'm going to scroll up and grab these command lines again. And now we're waiting another 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait a little bit longer. That wasn't a thumbs up. Come on, that was 10. Anyway, paste it, send the blank line, and now it's handled by smiley 2, even though we took a really long time to send it. So that's how protocol declarations work. The whole point is just to be able to force Linkerd to know what protocol is going on, even if protocol detection fails. All right. Once again, if you have questions, toss them in the Slack or toss them in the chat here. It doesn't look like anybody has questions, which is always a scary sign, but probably a good one. All right, GitOps compatible multi-cluster. Nobody likes Linkerd multi-cluster link, the command. This kind of makes us sad, but we get it. I mean, running CLI commands is difficult to automate, especially if you're using GitOps. Running Linkerd CLI commands every time you upgrade is even harder to automate and even more of a pain. And this is just unpleasant, right? The root cause of this unpleasantness is that Linkerd multi-cluster link always combined two separate things into one really ugly block of YAML. On the one hand, it included the credentials that you need for service mirroring to work, which is fine. I mean, that makes sense. But it also included all of the YAML to define the controllers that were doing the service mirroring, which is much weirder. And the fact that those controllers were present, that was the reason that you always had to rerun Linkerd multi-cluster link on upgrade, because you had to upgrade the controllers. So in Linkerd 2.18, we separate those two things. The controller part of this, the part that actually has the compute that's looking at services and mirroring endpoints and doing all that stuff, that is now handled by Linkerd multi-cluster install itself. At present, this means that you do have to use a values file to tell it which clusters you are going to link. That may very well change in the future, but at the moment you have to do this. It's not that bad. And then there's a new Linkerd multi-cluster link gen command, which handles the credentials. It outputs YAML like Linkerd multi-cluster link used to, but you can do whatever you like with it, is the point. You can apply it directly. You can commit it in GitOps, whatever you need to do. It's just YAML, it's there. And as an extra bonus, since it no longer has the controllers in there, you don't have to do a relink on upgrade, which is nice. Linkerd multi-cluster link for the moment still works. It is deprecated. It does exactly the same thing that it always did for the moment, other than tell you, hey, this is deprecated, please use LinkGen instead. But for the moment, it's still there. This is a surprisingly simple summary for a surprisingly difficult piece of work. So let's go over and take a look at it. All right. What we're going to do here is we do not actually have time to go and set up and do the whole GitOps thing, but we will demonstrate linking the clusters together. And we will also demonstrate the fact that you can run LinkGen and then just save the output and then install the YAML later to actually link the clusters. But the first thing that we're going to do is we're going to verify that our clusters really are using the same trust anchor so that we really can do a multi-cluster setup with them. This command looks terrible, but it's not that bad. In the East cluster, we are going to look at the Linkerd identity trust roots config map. Within the config map, there is a key, the cabundle.crd key in the data dictionary that has the public half of the trust anchor itself. So we will use step certificate inspect to look at that and to output it in JSON. We will use JQ to look at the JSON. In the extensions dictionary, there is a subject key ID that uniquely identifies the trust anchor itself. So we're going to look at that. We do that and we get a long hexadecimal number. Excellent. If we repeat the same thing for the West cluster, none of the rest of this command changes. We should see exactly the same number. And if we don't, that will be a problem. Fortunately, we do see exactly the same number. So we're good to go. We can do multi-cluster. The clusters share a trust anchor. Everything is great. When I set these clusters up, I set them up in such a way that they can do direct pod-to-pod networking. If you are looking at the repo for this, there is a long and complex, okay, it's not that complex. There's a longish Python script called local cluster, which handles all of the mechanics of doing that for both kind and K3D. So looking at that is probably a good thing to do. Incidentally, I would love for there to be a simpler way to do this. So yeah, suggestions welcome. All right. We're going to run multi-cluster install to install multi-cluster for the East cluster and for the West cluster. And like I said, we have to provide values to tell each cluster what we're going to link it to. So our East cluster, we will be linking to the West cluster. We also need to provide gateway equals false because we're going to be using federated services, and federated services require that pod-to-pod networking I was talking about. So we're going to go ahead and install that in the East cluster. We have exactly the same thing, kind of mirroring that for the West cluster, where we will link the West cluster to the East cluster. And we're going to repeat that install. Also worth pointing out is that we have done context west on the Linkerd command, and we've done context west on the kube control command. This is important. If you run multi-cluster install in the West context and mistakenly apply it to the East cluster, things will get very confused. So here we're going to check multi-cluster in the East, and it's fine. It's not doing very much right now. For the West, also fine. Still not doing very much right now. Okay. Next up, we're going to generate our link resources, but we are not going to apply them yet. We're just going to save the YAML to do whatever we want with later. Here, we are using the East context. We are explicitly calling this cluster East, and that East in the cluster name has to line up with the East in the values we pass to multi-cluster install. And we're going to dump that out into an eastlink.yaml file. We also, again, set gateway false, very important. Then we'll repeat the same thing in the West context, and we're going to name the cluster West, and we're going to dump it to westlink.yaml. Just for the fun of it, we can also run the same thing using the old Linkerd multi-cluster link command as opposed to linkgen, solely so we can see how much more awful that YAML file is. Here's EastLink, so that's a secret that is providing the credentials for the East cluster. And then we see what looks like remarkably the same thing. What's going on here is that one of them is in the Linkerd namespace and the other one is in the Linkerd multi-cluster namespace for various important technical reasons, TM. And then we have the link resource itself. So that's pretty simple. If we look at the old link format, we see the same secrets, which is great. And we see the link resources, which is great. And then we see a cluster role and a cluster role binding and a role and a service account and a deployment. And that is much less fine. That's pretty awful. LinkGen is cleaner. The output is shorter. More importantly, you can stick the output in GitOps and then not have to worry about it across upgrades. All right. Once again, I'm going to install faces so that we have a way to prove that things are actually running and that the multi-cluster linking actually worked. And in the process, I'm also going to do a bit of a demo of federated services. And one of the things, a couple other things really that I think are really cool about federated services. So I'm going to install faces in my east cluster, same way I did in my west cluster. So we will end up with faces running in both clusters. Just bear with me. Again, the values we're providing here are just turning off faces' normal, horrible error behavior. The point of faces was originally to demo a bunch of resilience patterns. So by default, it comes up with everything failing 20% of the time. We don't need that for this demo. Let's make sure it's running. It is running, great. And again, we can grab the load balancer IP address for the faces GUI service, which is pretending to be our ingress controller. And we can flip over here. Now this, if you look up this IP address, it ends in .32 as opposed to .16. So I should have a tab here that's already on .16. I do. Let's reload that. And here we go. And you can tell the difference, right? Because we have no hard-eyed smileys here and everything is blue. This is running in the east cluster. All right. Now, we're going to set up federated services for smiley and for color. And we do that by labeling the services in both of the clusters. Please note I said label, not annotate like you do for kind of, normal mirrored services. That was a thing I had to double check. So in each cluster, we're going to label the smiley service, then we're going to label the color service. And I want to remind you that we have not actually linked to the clusters yet. So this is kind of a cool thing that you can do with federated services. You don't actually have to have multi-cluster running for federated services to come up and do something sane. It's not clear to me, you can't really do anything more with federated services in a single cluster environment than you can with normal services in a single cluster environment. But I love the fact that you can get the federated service running before your clusters are linked at all. And since we have not linked our clusters, if we take a look at the endpoints behind our smiley services, we're going to see that they are completely disjoint right now, because one of them is in one cluster and the other one's in the other cluster. This command takes a little while, by the way. So the fact that it's taking a little while is expected. And again, you can see we have one endpoint in each of them and they're not the same endpoint. That makes sense. Now, we will now go and we will beat on the faces demo to speak directly to the federated services. Little known, little advertised fact about the face workload is that you can use environment variables to tell it what to talk to for the smiley workload and what to talk to for the color workload. So I will do that now to basically point it to the federated version rather than just direct to smiley and color. We could also do this by installing HTTP routes, but I kind of wanted to show that federated services can do some really cool stuff, whether or not you're using route resources as well. If we do that, it's run. You might have noticed that there was no change in the application. So, it just did the right thing. It did a rollout restart. Everything was great. Now, we are going to scale smiley in the east cluster down to 0 replicas so that there's nothing behind it. And this is going to break everything, because our application can no longer talk to that smiley workload. Everything is broken. So we will now actually link the clusters together. And as I do this, a couple of things. First, pay careful attention to the contexts. We are applying the east link to the west cluster, and then we'll apply the west link to the east cluster. Applying the east link to the east cluster would be linking it back to itself, which is a little weird, especially if you're doing pod-to-pod networking. The other thing going on here is it's a little instructive to think about what would we expect to happen. If federated services are doing their thing, then we should just pick up the smiley endpoint from the west cluster, right? So let's see what actually happens. There I've linked west back to east. I didn't actually need to do that because we are only doing stuff, but linking east to west instantly gives us working smileys again. This is a thing that I really, really like about federated services. If I go through and check the endpoints again, then in my east cluster, I will now see exactly the same single endpoint as in my west cluster. Give it a few seconds again. And yeah, this is the thing that's really, really cool about federated services is that they just act like services. So as endpoints come and go, they come and go everywhere in your multi-cluster environment. And, service-based load balancing just works. All of the stuff that Linkerd gets to do just works. It's really cool. So I'm now going to switch the smiley workload in the west cluster to return hard-eyed smileys. So when I do this, in a second or two, we start seeing hard-eyed smileys. I'm going to do a reload there just because I kind of want it to be behaving a little bit better. Sorry, in the visual sense, right? It was doing these bursts, and I kind of want it to go down the cells one at a time. Obviously, that means that our smiley workload in the west cluster is working. But now I'm going to bring back the smiley workload in the east cluster, which should cause another endpoint to appear in my federated services. But that east smiley will still be giving us the grinning smileys instead of the hard-eyed smileys. So we should see a mix of the two as my new replica comes back up. Got to give it a second here. There we go. The other thing that's happening here is you might notice that we're not getting a nice, neat half and half interleaving thing going on here. And the reason for that is kind of interesting, actually. The first one is that Linkerd doesn't really do round robin, like strict round robin load balancing. Linkerd does EWMA based on latency. And when you're running a workload in one cluster versus a workload in another cluster with federated services, you would expect the service in your local cluster to end up with a local latency. So Linkerd will, a lower latency. So Linkerd will end up preferring it. And what happens here, of course, is that we end up preferring that one. So we send a bunch of stuff to it, and that drives the latency higher, right? So what we're seeing here is kind of I don't want to call it a pathological case, but we're seeing an interesting thing about the implementation details of EWMA. In practice, what that means is, first, we will tend to prefer things in the same cluster, although if you really want that behavior, you need to go to Buoyant Enterprise for Linkerd with Hazel. Hazel's cool. But also that with really small numbers of replicas, you may or may not see exactly what you would naively expect to see if you just think about it for a second. Another thing, we already had an HTTP route in the west cluster that was routing smiley traffic to smiley 2, which was already returning hard-eyed smileys. But when we started routing stuff over to the west cluster with our federated service, we saw grinning smileys, not hard-eyed smileys. This is the main gotcha of Gateway API and cross-cluster setups. Routing decisions happen where the request happens. So the request was happening in the east cluster, which did not have that HTTP route. By the time it got over to the west cluster, it was going direct to an endpoint. The routing decision had already been made. The HTTP route in the west cluster did not have any opportunity to take effect. If you think a little bit about how it would look to loosen that restriction and have HTTP routes go to HTTP routes, there are some major disasters that end up being possible with that sort of scenario. The simplest one to reason about is a circuit or route where you can have an HTTP route refer to another HTTP route, which refers back to the first HTTP route. And that's the simplest disaster to reason about. That is why Gateway API does not work that way. So always remember, Routing happens where the request happens. And that is very important when you're dealing with multi-cluster and gateway API pretty much everywhere, whether you're running Linkerd or not. Okay. There are, of course, a lot more things in Linkerd 2.18. These are just some of the highlights. But all of these highlights definitely do get into some real-world problems. Let's talk a little bit. Actually, before we talk about gotchas, let's talk a little bit about other things in 2.18. We have vastly improved OpenTelemetry support. We went through and did a bunch of stuff to try to make Linkerd better about obeying modern OpenTelemetry conventions and giving OTel collectors what they expect. We did an entire SMA on this in February with me and Michele Mancioppi of -0. If you are interested in OpenTelemetry, I would strongly encourage you to check that out. It was pretty fun. There are a couple more things that we're trying to do to make this even better, so keep your fingers crossed. We have an experimental Windows proxy now that's real, and it's experimental, but we would encourage people to run it. It is geared more towards mesh expansion onto Windows workloads than to running Kubernetes nodes on Windows. We are very interested in feedback on this. If you are interested in Windows, let us know. You can drop a line in workshops or ping me directly, or however you want to do it. Federated services. Federated services get an interesting new feature in 2.18 where we can propagate labels and annotations from one element in a federated service over to the federated services in other clusters. You can also filter that stuff so that you don't end up replicating cluster-specific data. This is a thing that we had asked for a few times. Most notably, that means that if you're using Linkerd annotations to configure retries and things like that, those will automatically be replicated for you, which can be nice. We also changed the way you configure the CPU and threading stuff for Linkerd proxies themselves. Used to be that you had to say things like, oh, you are allowed to use 2 CPUs. And you can now say things like, you can use half of the available CPUs, but not more than 2, or things like that. So if you're running Linkerd on big iron in weird situations, this can be a little bit more comfortable sometimes. All right. We will now talk about gotchas, because this is Service Mesh Academy, and that's what we do. There are a few. First off, Linkerd 2.18 has 3 possibly breaking changes, or possibly not. The first one, the proxies, if you have 2 meshed workloads, when they're communicating, by default, they will now communicate over port 4143 rather than on whatever port the clients were using in their connection. So it used to be with 2.17 and prior, if you make a connection from the face workload to Smiley's port 80, then the face proxy would talk to the Smiley proxy on port 80. Now we multiplex everything over port 4143. There are reasons for doing this related to protocol declarations. It gives us a way that we can actually pass along protocol information to the remote proxy, which can be really important. But this is a thing, right? We don't really expect that this will break anybody, but I wanted to mention it because it's possible that folks who have really strict network policies might run afoul of this. I guess, maybe. We're pretty sure that if you're using Linkerd, you probably have that port open anyway, but just in case, wanted to mention it. Another change, our default tracing protocol changes to OpenTelemetry instead of OpenCensus. Again, I could be breaking. We pretty much expect that everybody was already using OpenTelemetry, but you never know. And finally, the authority label has been removed from our metrics, and for inbound metrics, the hostname label will have an empty value. You can reconfigure this if you really need the old behavior. What we were finding is that the authority label, authority and hostname, tended to just dramatically increase the cardinality of a bunch of these metrics to no good effect, because people tended to never bother looking at them. All right, other gotchas. You still need to create gRPC routes if you want to get really good gRPC stats. And again, we may end up doing linkerd.io/grpc for app protocol later, but for the moment, you have to do kubernetes.io/h2c, but that means HTTP2. So if you want Linkerd to do gRPC metrics, go ahead and create a gRPC route. And yeah, this is one where we recognize people may have strong opinions about this, so let us know. Love to hear from you. Likewise, if you have a service where you have explicitly set the app protocol to linkerd.io/opaque, the only thing you can attach to it is a TCP route. Or a TLS route. Misspoke. It does not make sense to say this protocol is opaque TCP and then try to attach an HTTP route to it, because HTTP route is all about HTTP routing, and you've just declared that the particular thing there is not HTTP. So that's the reason for that limitation. Likewise, if you have a service that's marked HTTP2 cleartext with kubernetes.io/h2c, you can attach both a gRPC route to that and an HTTP route to that. If you do, the gRPC route will win, which is probably what you wanted, but you never know. Something to be aware of. One final gotcha here. If you are running edge releases, pay more attention to the version than you normally have. Please, please, please check the edge release roundup posts on this one. Several of the edge releases on the way to 2.18 had more caveats than we typically like. I would personally say if you are running something, an edge release from the 2.17 days and you want to switch to an edge release from the 2.18 days, just go directly to 25.4.4 or higher. Do not mess with any of the edges from 25.3 or the early 25.4s. Just go straight to 25.4.4 and have done. You can read the edge release roundup posts to see why I say that, but there are some interesting and weird caveats for some of those releases. And that's it for Linkerd 2.18. If you are watching, we would love to hear from you about Service Mesh Academy, how we can make it better, what you like, what you don't like, all that stuff. Scan the QR code. We promise that the feedback will not take more than a few minutes to give, and we will really appreciate it. Other things, shameless plugs. I've been running Buoyant Enterprise for Linkerd for this demo. You should try it too. It's really cool. Scan that QR code or go to buoyant.io/enterprise Linkerd. And we have some new self-paced courses now, actually, at I think it's buoyant.io/learn, but scan the QR code. Oh, no, sorry, it's buoyant.io/SMA. You can see those as well. We have Linkerd 101, or Service Mesh 101, which we've had for a while, but we also have the shiny new Linkerd in production course, which we would love to hear feedback on. Up next in Service Mesh Academy on March 13th, we're going to talk about WASM with Linkerd with WASM Cloud maintainer Jonas Berges, hopefully. Sign up today, buoyant.io/SMA. Hopefully, we will hear from you there. And that is it. So if you have questions, now is a great time. If you do not have questions, that's okay too, I guess. But I will give this 30 seconds or a minute or so just to make sure that we have a chance for folks to send things in if they have questions. And if not, I will see y'all in June. I'm staring at my Slack window, and so far, nothing there. Somebody is mocking me for saying, did I say March 13th on that slide? I bet you I did. Ooh, yeah. So, like I was saying, up next on June 13th, even if I could do time travel, I don't think there's anything terrible happening in March. Ooh, I could go back to March and get some more skiing in. That'd be kind of cool. Yes, March. Oh, it's June 19th? Wow, how did I get both of those wrong? That makes me sad. All right. There, done. Anything else other than well-deserved mockery for getting the date wrong on a slide? That makes me very sad. All right. I believe that we are going to call it then. Thank you all for attending. Much appreciated. And hopefully we'll see you next time on June 19th. We're not waiting until March 13th of 2026. We will be back here June 19th, 2025. See you there. Thanks much.